Hello and welcome to another edition of AI Impact Talk with me, Thembekile Mkhototo. So picture this, being able to build an energy efficient home using AI before construction has even begun. A crucial conversation, right? When you consider where the world is going in terms of energy efficiency and the fact that if you live in South Africa, energy has in fact become a bit of a scarce resource. Well, today we've got someone with us on AI Impact Talk who's an expert, if you will, at doing this, and she's going to tell us how we can achieve that goal. I'm lucky enough to be joined today by Zanele Ngema, who is director at CKR Consulting. She works in the space, and we'll talk about how all of this would affect, for example, engineers as well as architects when you talk about energy efficient homes or buildings more broadly. Zanele, a very warm welcome to AI Impact Talk. I hope I did your work justice there. Let's talk about energy efficiency, building, and AI. How does it all come together?
Thank you for having me, Thembekile. So if we're going to talk about that, then I'll take you just step back.
Yes, the basics, please.
The basics. So when I started in 20 years ago in the industry, we were still sketching our designs on 2D, right? You print it on 2D paper. That's what you see. That's it. And then you do sections. You had to sit and do sections all by yourself. And before that, the engineers before us had to mark them up on paper. That was it. So from paper to 2D. Now, 20 years on, we're now doing 3D. So from that, it's really been quite a huge leap on the engineering side and on the architectural side. So from there, then it added if you look at the engineer, more on the engineering side, right? That's where the energy efficiency or comes in. Yes, on the architect it does, because we as engineers will specify to the architects that, okay, for us to have an efficient building here, you need to install you need to build this as this.
Here's what you need to do.
Yeah, so like a house, you need to build this house the walls around this house need to have the U value, which is the heat transfer coefficient. You need to have that heat transfer needs to be limited on that wall. So it's quite specific when you look at what we do on the standards, because we base our designs on the standards.
And do you find that there's an increasing amount of consideration for that, given our energy situation in the country? It's been tough. So everyone wants alternatives to the conventional grid, but also at a cheap cost, relatively cheap cost.
A relatively cheap cost. So we'll look at that, and then we'll say, okay, from there, what can we do now to make this, whatever we're putting in this house, to be energy efficient? So what AI has done for us is that it takes all of that, what I've just mentioned from when we started sketching, it takes all of that, and you, by simple clicks, you get everything that you need in that 3D model. So you do that, and they have, the softwares that we use has included, is that you have the weather data for most of the locations in the world. So you can click on it and say, this house is in Durban, for instance. And if the house is in Durban, what are you putting in? What walls are you building this house with? Which windows are you putting in? Where is it facing? Is it north facing? Is it, all sorts of things. So you look at that, and that's where AI has brought us to this point.
And I mean, before you arrived, there was a lot of conversation here about digital twinning. I was like, what is digital twinning, and how does that tie into everything?
So digital twinning is quite exciting for us. So digital twinning is it's a 3D, it's still a 3D virtual model, but with it comes so much more, because you have all the information of that particular, so you'll have of that particular asset that you're doing or that you're building. So for a house, for instance, you'll have exactly the type of windows you're putting in, where they are, the type of curtains you're putting in. If you're putting in drawn curtains or you're putting in blinds, you're going to have all of that, and you're going to have your appliances. So everything in that building is in the twin. So the twin is reflecting reflective, of what the real life model is going to be. That's before you do it, right? But there are ways to find. So if you have an already built house, there are ways to get a digital twin for that specific building.
And would it be a complicated process, or how easy is it to do?
It's not really that complicated. So we
says
actually
the engineer. The rest of us are thinking, my goodness, how?
We're actually doing one at our offices at the moment. So we have a project that we're doing where you first need to scan. So you have somebody come in and they'll scan the building or the room that you want a digital twin of. From there, they'll have a point cloud software that they're going to use to put this together. So you're going to have, from that scan, you're going to have all that information and you're going to put that into a model. Then from there, you know the services that are there. Because when we do designs, we give our clients, or we get as-built drawings or as-built models. We use that. So when you're doing a design, you're doing a design based on a drawing that you've got. So you use that to put into that model, then you have a complete digital twin. And
is synergy then an easy thing to achieve? I mean, you already have, for example, I'm thinking of 3 people in my mind. You've got whoever, let's say homeowner or the building owner, right, who's approached you. You've got the architect and you've got the engineer. I'm curious about the dream versus the practical thing and the clash of the wolves.
Yeah, so that was difficult before 3D, before the digital twin, or before we could even go into 3D. Because now you have the VR glasses, right? So when you've done your model, you give to the owner to wear these VR glasses. When you're wearing them, you're in the house. They're in the property.
It's a virtual reality, right?
It's a virtual reality. So you get in, you can see where your aircon is, you can see how high your walls are, you see everything. So it has bridged that gap, if I may say that because now the owner is going to know exactly what he's in for.
And in terms of that simulation then, how accurate, for example, just from the digital twinning, etc., how accurate is it in then getting to the final product where you've got a home that a person or a building where the owner can say, this is truly energy efficient. It speaks to what we wanted.
So it's as accurate as the information that is given into the twin. So any information, if there is, because it uses real-time information. So if I change my air conditioning design, and instead of putting in an energy efficient design, then I put in something that is not so energy efficient. And yet I leave the twin, I don't update the twin, and I put that into the final product. Of course, though, that's not a twin. So it's as accurate as the data that you upload into the twin.
So it comes back to, as that's been going on, in fact, since we started the series, the conversation about how what the humans put in ultimately determines the helpfulness of the tech.
Of course. It's all, as they normally will say, garbage in, garbage out. So whatever you put in, you need to understand that it's going to affect how the end product is going to work. So if you're putting in something that you haven't told the owner about, but you put it into the twin, they're going to see, and they don't like it. So they're going to see it in real life and be like, I didn't want this. This is not what I asked for. So we need to be conscious of that.
And what about flexibility? Because that's I find that's become, or it's always been, in fact, quite important in a building project, right? The ability of people to adjust to changes. If you've ever built anything, you know how the plan and what you find when you get to the site can be so different.
It is quite. So it's very important that when you're starting with the project, you get the buy-in from the client that you're building, whatever you do, or whatever, not even a building, you get a buy-in from the client. They know exactly what they're getting. And with this 3D, they will know exactly what they're getting. And how the energy efficiency, I mean, you mentioned that how correct is it in running in real time at the end of the product. So we simulate that as well. So as we're simulating it, because we've been, in the industry for quite some time. So
20 years you've been around. Legend.
So we sort of know what to expect. There's been mistakes that we've made. I remember my very I'm not going to say it on air, but it wasn't as bad.
Was it a big mistake?
It wasn't that big. Okay, let me say it. Okay, so I was designing a building in Durban. Now, Durban is very humid. And I had this air distribution device that takes out the air into and then and sort of distributes it into a lobby. Now we were getting in, and this device was made of steel. And it was at reception. So the air is, you've got this humid air constantly coming in, and it started dripping.
So the receptionist almost paid with their life.
I almost paid with my life. But you see, so those sort of things, when we had digital twinning, it would have picked it up. It would have picked it up. That it's steel, you in Durban, it's humid. There is no wind lobby. So that is going to leak. It's going to drip. And
it's fascinating. I think what's most fascinating for me is just the number of factors that we take for granted in building, that when you bring in actually the professionals, because most of us, when you build, you just think, oh, okay, I'll just speak to an architect, get a builder, and that's it. And then once you move in, you go, this room is cold. In your house, there's always a particular room where you're like, we are freezing in here. Because you could have just called on Zanele.
Exactly. So it's actually, you actually right. To be quite honest, not that we blowing our own horns as engineers, but engineers are very crucial when you're building, because you'll get an architect. Not that I'm gonna downplay their role, but we model what the heat transfer is going to be we model how comfortable
you go beyond aesthetics. Basically,
we model how comfortable your occupants are going to be in the room. We want you as the owner to be comfortable. Now you get into a room and it's cold in winter, and in summer it's hot. So come on. So those type of spaces, we here to make sure that doesn't happen.
Is it expensive?
No.
Is it something that we could all do?
It is something that we could. It's something that we can all do. It really is. It's not expensive. I don't think it is. Let me put it that way. I don't think it is expensive, because remember, this is the house that you're going to be staying in for probably a long time. So you want to be comfortable, and you want your visitors to be comfortable, or whoever comes into your space to be comfortable. So for that thermal comfort, I don't think it's expensive.
Earlier, I was asking you about the South African context. Our electricity problems. I won't go into them. But there's the ongoing conversation about living green, climate change, etc. We're seeing a change, in fact, in climate in South Africa, right? We're seeing extremely hot summers, a rapid rainfall, snowfall even. How much is that shifting, if in any way, the work that you do, or influencing, let me say, what you now need to pay attention to, rather, when you go in for that initial consultation, etc.?
I know I've been talking up and saying energy efficiency. Yes, we've been looking at it, but we've been also saying we've been giving clients options. Like you can install this, that, or the other. These are the options. These are the costs, and this is more efficient, and that is less efficient. Which one do you pick? We've been saying that, but now it's not like that. Now it's according to regulations. Your building needs to your energy consumption for the building needs to. This is the limit. You can't go above this. So we work backwards from there and say, okay, if you don't want to go above this, this is the system that you need that's going to help you with that. It's changed it in that sort of sense, because also the regulations have also changed recently for residential buildings, for new residential buildings, that is. So that's why I'm saying for homeowners, it's critical that you also think about having an engineer as part of your professional team, because we're the ones that are going to look at it and say, okay, it is comfortable. Yes, your energy consumption is going to be less, and it's okay for that. So I would say it's changed how we look at the designs and how we design more efficiently. It's changed a lot.
And I'm going to go back to the tech we were talking about earlier, digital twinning.
Yes.
We're trying to get the sort of infrastructure going that remembers things, right? That is able to tailor make a solution. We've spoken to that to some degree. Is that largely possible with the models that you're working on?
Yes, it is. So what we are so before digital twinning, there was a control system that we will still use, called a BMS system. So it's a building management system. That system will have the HVACs on it, will have the security in it, and some power systems in it. But with digital twinning, what we're doing is we did have control and we monitored the systems. But with digital twinning, you're looking overall. You're not just looking at certain things. So you're looking at how the building is performing.
Holistic approach.
Holistically. So if you have, and you're also looking at how the people, the patterns of the people, how they're using the building. We didn't look at that. And
we don't factor that, right? I won't name names. You walk into some places and you go, you guys have and I'm not talking about residential buildings, an office block, and you're just like, you guys have way too many people in here for this building to work.
Sometimes you do, yeah.
And that affects, does it not, energy efficiency? It
does, of course it does. Because remember, these people need to use lifts. These people are going to be using, it's plugs. How many plugs are they just for power? And you need to cool it down, or
the equipment might be at risk. For example, in broadcasting, you have critical infrastructure that needs to stay cool.
That's it. Now you're going to have people, sometimes people just say, okay, just use natural ventilation, just open windows. What happens in winter? What happens in winter? And these spaces are packed. I know some of the spaces you're talking about.
And even with homes, right? So people need to say to you, there'll be 4 or 6 of us using a space full time.
But even if they don't say, we do sometimes have a way of designing without really having more information. But it helps to have more information, because then you're designing for the correct number of people. That helps.
Just in the building, you go, we've opened the windows. We've tried everything, but we are sweating. Is it an easy space, Zanele, to get into? Because when you look at the sort of work that you're doing, was it the direction that you always knew you were going to go, for instance? And are younger engineers seizing the opportunities available?
Oh, they are. So to just go back, it wasn't the space that I thought I was going to get into. When I started studying, my bursary was through a mining company. So I thought I was going to go that route until my journey was sort of changed and I went this route. But I'm glad I came here. I'm glad I'm in the built environment, because what we do is actually, you don't see it as being glamorous, but it keeps the wheels going. The work that we do is amazing as engineers. It really is. And for youngsters, I've been pushing more, because I've been noticing that there's less of the young ladies that are coming through. So I've been pushing more on getting the young ladies to come through and do this. It's hard. It's hard.
Are people intimidated, or is the space sometimes not welcoming?
It wasn't welcoming previously, but now we're here. So
you're an example.
Yes, I'm here. So it's for them to just come through and stay in engineering. It's a very hard. The sector that we're in is very hard. You have to work hard. you have to be competent in what you do. You have to work hard in staying competent in what you do. So, you need to keep learning because there's new technologies. I mean, we're talking about AI now. You need to know what's going on in that
I was
space.
actually going to ask you that about how quickly the tech changes. We're talking about AI. Like, is it every year, every few months where you go, oh, new thing, need to learn how that works?
No. And in engineering, it's not that. But on the electronic side, it's actually that. I was speaking to my electronics director just a few weeks ago, talking about something on electronic, and he's like, in security, it's changing every year. So you need to keep up with that. But on the mechanical side, it takes a while, maybe 5 years. But then you need to keep abreast. You need to know what's going on so that you can give your clients better options.
And are we moving at the same pace as perhaps our global counterparts?
We are lagging behind a bit. I mean, looking at, because we're also involved in data centers. Data centers now, they've got I think it's a liquid cooling sort of system that they've got. We still a bit, it's new to us. So it's scary because we thinking it's liquid. So you're putting this server in a liquid. It doesn't make sense. It's not making sense. But it's not about that. It's about, it's a technology that works. We need to give it to our clients. So we sort of behind a bit.
Just a little bit.
Just a little bit.
So lastly then, as we end, where do you see things shifting in the next 12 months, next 5 years, next decade?
No, they're shifting, I think, in the next 12 months.
And where are we going to?
So with digital twinning, I think it's going to be a place where we have energy efficient buildings. We have more control of how we maintain the systems that are in the buildings. It's going to be easier for asset management, for owners of buildings, and for if you're, well, I wouldn't say asset management then in a residential space, but more in commercial buildings. I think it's where we should be looking at as an engineering fraternity.
Zanele Ngema, it's been so good to speak to you. Thank you so much for joining us.
Thank you.
Thank you as always for watching AI Impact Talk with me, Timbekile Mkhototo. I hope you found this conversation as insightful as I have, and that next time you work on a building project or have a building project, Zanele is the woman to speak to, and she'll help you in terms of looking at what ways you can look at for an energy efficient building in particular. We'll see you on the next one. Bye-bye.